Here's problem 422. A motorcycle daredevil wants to ride up a 50-meter ramp set at a 30-degree incline to the ground. It will launch him in the air, and he wants to come down just so he just misses the last of a number of 1-meter diameter barrels. If the speed at the instant when he leaves the ramp is 60 meters per second, how many barrels can be used? Alright, so we have a ramp that is oriented at a 30-degree angle, and it's 50 meters long, and at the end of that ramp we are going to launch our motorcycle. So the motorcycle, how's that going to look? It's going to go off at a 30-degree angle as well, off the ramp, and the velocity of the motorcycle is 60 meters per second. So we're going to go through projectile motion like this and land somewhere over here. So our initial height for this motorcycle is going to be equal to 50 meters times the sine of 30, which is actually going to be 25 meters. We're 25 meters off the ground when we launch, and we're going to end up back on the ground. So, alright, that sounds good. What else do we know? We've got our launch velocity. We need our x and y components of that. So our initial velocity in the x direction is going to be v naught cosine 30, and that will be 60 times the cosine of 30, and that actually is 52 meters per second. And our initial velocity in the y direction is going to be v naught sine 30, so that would be 60 times the sine of 30, and that would be 30 meters per second. Alright, what else do we know? Well, if we defined up as positive for our initial y velocity, then our acceleration in the y direction is going to be a negative 9.8 meters per second squared. And if up is positive, then our initial velocity would be positive, but our displacement ultimately down to the ground, if we consider this displacement down to the ground, delta y, is actually going to be a negative value. So our delta y is going to equal eventually a negative 25 meters as we make our way back down to the ground. So if we look at this problem in the y direction, we have displacement delta y is equal to initial velocity in the y direction times time plus 1/2 acceleration in the y direction times time squared. Alright, our displacement is going to be negative 25. Our initial velocity in the y direction is 30 times time plus 1/2. Our acceleration is going to be a negative 9.8 times time squared. So we are going to have 4.9 t squared minus 30t minus 25 equals 0. We're going to have ourselves a quadratic equation, and we can solve this for t. So t will be equal to a negative b, which is going to be a negative 30, plus or minus b squared minus 4 times a times c, negative 25, all that square root over 2 times a, 4.9. So this is going to be 30 plus or minus what's in the radical, square root of 1390, all over 9.8. So this will be 6.86 seconds if we use the adding, the plus sign, and a negative 0.743 seconds if we use the minus sign. Well, we don't know how to go back in time yet, so we don't choose the negative answer, so we're just going to use the positive time. our displacement in the x direction will equal initial velocity in the x direction times time plus 1/2 times acceleration in the x direction times time squared. But we have no acceleration in the x direction, so this is equal to just our initial velocity times time, which is 52 meters per second, times our time that we just calculated, 6.86 seconds. And hence we are going to have a displacement in the x direction of 356.7 meters. So if we had a bunch of barrels, all of them 1 meter in diameter, then we will cross over or pass over 356 barrels. So that's our answer. We will make it over 356 barrels. Gives you more respect for what a daredevil has to calculate, because they have to know physics in order to figure this out.